Hello, sorry for being late. I just need to give me a minute, plug in my computer. Guys. All right, I'm gonna get started in a minute. All right. Sorry, I have to start the class late. I promise you we're not going to stay here for too long today. Well, we're going to finish the material, but I don't imagine we're going to stay here for 2 whole hours. Share my screen. All right. So let's see. All right, there might be some internet issues with my end. And if that happens, I would say just don't leave, be patient. If you do have to go somewhere, I completely understand, but just try to stay in this class during this time. I think you're going to benefit from it. So if you have any questions about the recent exam that we took, exam 2, feel free to let me know now by unmuting yourself or leave a comment in the chat box. If you don't want to share it together, feel free to let me know through email or at the end of class today. I have not started grading it yet, but I will. And I know you're probably anxious about the first exam. I apologize. I'm still behind with all the grading. I promise you I'm going to try to get all the exams done sometime this week. I know the term is coming to the end soon. You definitely want to know how well you do, right? But do your best. I'll try to get back to you with all the grades as soon as possible. Okay, any questions before we get started? All right. Again, let me know if you do have any questions, comments, just either email or, well, email is probably the best way, right? Just let me know. And there'll be a homework assignment sometime available sometime later today or tomorrow morning, but it's coming. It's not, well, I'll try to keep in mind that not to make it too long. But there's a lot of good material in those sections. That's nice to practice about. All right, so anyway, so today we're going to talk more about trig functions. So this is the 5.3 more trig functions. Well, let me just quickly remind you what we talked about before. So we talked about using unit circle to find trig functions. For example, if you have an angle somewhere here, and that's a terminal side corresponding to this angle. Let's see, this angle is, let's just say is 2 pi over 3, for example. And in order to find sine cosine of this angle, let's call it alpha. So sine, I don't even need to use alpha. So sine 2 pi over 3 is equal to the y coordinate of this point on the unit circle. So this is the x, y, the x corresponding to cosine of the angle, the y corresponding to sine. So if we want to know sine 2 pi over 3, we just need to know the y coordinate of that specific point on the unit circle. And to do that, so what we did was we draw a vertical line, dotted line all the way to the x-axis to create a right triangle. And then we need to know this reference angle between the terminal side and the x-axis, right? That reference angle is always going to be less than 90 degrees, between 0 and 90. And if you're familiar with this, 2 pi over 3 is corresponding to 120 degrees. So this is 60 degrees angle. And using the special right triangle, I suggest that you memorize it. So if this is 60 degrees, this is 30. And because it's a unit circle, so the hypotenuse is 1. This side in the x direction is going to be half. This side is going to be root 3 over 2. Therefore, we can write down the xy coordinate. Going to be the x coordinate is going to be 1/2 in the next x direction. So that's going to be negative 1/2. The y coordinate is going to be positive root 3 over 2 in the y direction. And from there, we can write down the sine value for the angle. So sine 2 pi over 3 is root 3 over 2. And the cosine 2 pi over 3, that's going to be negative 1/2. You don't even need a calculator. You can get the exact answer here by using the unit circle, the reference angle, the special right triangle. Like I said before, you should memorize those 3 sides of this 30, 60, 90 special right triangle, and also the 3 sides of 45, 45, 90 special right triangle. So that's how we find sine and cosine. But today we're going to talk about, okay, how do we find tangent? And I forgot if we talk about tangent. So let's see. So suppose we already know that sine of an angle alpha is equal to the y coordinate of a point, and the cosine of angle alpha is equal to the x coordinate of the point. Then tangent of alpha, if you remember, it's always going to be sine alpha over cosine alpha, or sine x over cosine x. And if we want to think about in terms of coordinates, we can just say sine alpha is equal to y, cosine alpha is equal to x, y over x. But I want you to remember this part. This is the most important part if you want to remember the formula for tangent. It's always sine over cosine. That's going to help you everywhere. Don't try to memorize like y over x, because that's no need. Just think about sine is a y, cosine is the x, tangent is sine over cosine. And then we have this cosecant, CSC, so cosecant, CSC of angle alpha, so that's just going to be 1 over sine alpha, and secant, SEC of angle is equal to 1 over cosine alpha, and cotangent, COT alpha is equal to 1 over tangent. I just think about them as the reciprocal of sine, cosine, and tangent. Now, that's it. Very easy. I think it's the easy way to distinguish between cosecant and the secant. So cosecant begins with a C, and so that's cosecant. And the ratio is either 1 over sine or 1 over cosine. Which one is it? I always think if you have a C, then it's going to be a 1 over S. It's not going to be the same initial. And if you have a secant begin with S, then it's going to be 1 over cosine. The trig function in the denominator is not going to have the same initial as secant. So S, then somewhere you're going to have a C, so 1 over cosine. So that's how I distinguish those two. Maybe it's going to help you or not. So those are the 6 basic functions. So those 6 big functions that will show up a lot. And if you know those definitions, you can find the exact value for tangent, cosecant, secant, cotangent, if you know sine and the cosine to begin with. In the given example above, so when we talk about 2 pi over the angle 2 pi over 3, we know the sine and the cosine by using the unit circle to get the exact value. So let's see, we want to find tangent. I'm going to use this space right here. So let's see, we want to find tangent 2 pi over 3. Well, that's just going to be sine over cosine. And that's going to be sine is root 3 over 2 divided by negative 1/2. So how do we simplify this? Either you can multiply by 2 in the numerator and denominator, or we can multiply by the reciprocal of the denominator. So that's root 3 over 2 multiplied by negative. The reciprocal of negative 1/2 is negative 2 over 1, so just negative 2. You can write 2 over 1 if you want. So that 2 cancels, and we get negative root 3. So that's tangent. And let's say we want to find cosecant, 2 pi over 3. We just know that it's going to be 1 over sine of this angle, 2 pi over 3. So that's going to be 1 over root 3 over 2. So here we just have to multiply by the reciprocal. So that's a 1 times 2 over root 3. But we don't like to have a square root in the denominator, right? So we're going to get rid of the square root. So we multiply by root 3 numerator and denominator. So that's going to be 2 root 3. The denominator is going to be 3. Let's say we want to find secant, 2 pi over 3. That's going to be 1 over cosine. So that's a 1 over negative 1/2. This one is a bit easier. So 1 divided by negative 1/2, so it's negative 2. And then cotangent of 2 pi over 3. That's going to be 1 over tangent. Now, if you remember that, okay, never mind, just 1 over cot. Maybe I should mention this because they might save some work for some problems. So it's 1 over tangent. You can think about it as 1 over sine alpha over cosine alpha. That's going to be 1 times cosine alpha over sine alpha. So that's cotangent. It's a reciprocal of tangent. You can think about cosine over sine, but for me, I always think about it as a 1 over tangent to have less to memorize. So that's 1 divided by negative root 3. So that's going to be negative root 3. And then we have to multiply by root 3 to the numerator and denominator to get rid of the square root in the bottom. So that's going to be negative root 3 over 3. So that's cotangent. Any questions on those? All right, I'll be back in a minute. I'm going to open the room. All right, so that's one example. If you're just given a really nice angle, you can use the unit circle to find sine, cosine, and then from there with sine, cosine, and then you can do all the rest to find the remaining trig functions. But the 3 that I boxed, those are very important. Obviously, I didn't box those 3. They're also important, because you have to know how they're defined, right? Otherwise, you're going to have a trouble finding secant, cosecant, cotangent. All right, so let's look at another example. The next example I have says a point negative root 15 over 4, 1/4. As you can see, those are not the convenient values, right? Not root 3 over 2, not root 2 over 2, not 1/2. They're just a pair of numbers. It's a point. This point is the terminal side of an angle in the circle. This is my unit circle. This is the 1, -1, -1, 1. And at this point, negative root 15 over 4 and the 1/4. So that's going to be the y is 1/4 and the x is negative root 15. So it's right here. Negative root 15 over 4, 1/4. I already know it's on the unit circle. There's no need to check whether the hypotenuse is 1. If I pick a right triangle, it has to be 1 because it's on the unit circle. Right. So that's what we know. So here's a few questions. So find sine of the angle. Let's call this angle T, sine angle T, cosine angle T. And if we want to find tangent, we can do that. And if we want to find cosecant T, secant T, cotangent T, we can do all of those. So let me just quickly go through them with you. So because at this point, we don't know how big the angle is, right? But we do know the point on the terminal side of the angle and also on the unit circle, which is given. This is actually great because you don't need to do any calculation in order to find sine and cosine because it's right in front of you. Remember, all we did in the past, in the previous example, draw the right angle, find the reference angle, is to find the xy coordinate of that point, right? But here they're given. So immediately we know this first value, that's x coordinate, so that's cosine of the angle. The 1/4 is the y coordinate, which is the sine. So we already know that sine of t is 1/4. Cosine of t is negative root 15 over 4. And from there, we can find tangent, which is sine over cosine. So 1/4 divided by negative root 15 over 4. And we have to multiply by the reciprocal. So 1/4 times negative 4 over root 15. And don't forget, we need to get rid of the square root in the denominator. I'm going to leave that work to you. So eventually we get negative root 15 over 15. And we can find cosecant, secant. I'm not going to do all of them. I'm just going to find secant. And then you can work out the details for cosecant and the cotangent. So secant is going to be 1 over cosine of the angle T. So that's going to be 1 over negative root 15 over 4. 1 divided by a fraction is a multiplication of the reciprocal. So that's going to be negative 4 over root 15. But we don't want to have the square root in the denominator. So we're going to multiply by root 15, both numerator and denominator. So we get negative 4 root 15, denominator is 15. So that's C. All right, I left 2 out. So again, I'm not going to do those. You can definitely try it on your own. Any questions on those? All right. Let's see. I got more examples similar to those. All right. Let's see. The next one I have is so here's an example. So given the angle T, which is equal to negative 8 pi over 3, we find sine T, cosine T, and the tangent T. So again, what we do is we just plot the angle first on the unit circle. Which is negative 8 pi over 3. So this is how I'm going to draw. I'm going to start here on the positive x-axis going clockwise. So This is negative pi, so this is about pi over 3. This is about 2 pi over 3, 3 pi over 3, which is, sorry, negative 3 pi over 3, which is negative pi, 4 pi over 3, 5 pi over 3, negative 6 pi over 3, go back to where we begin, negative 7 pi over 3, negative 8 pi over 3. This is my terminal side for the angle. So the angle goes like this. Complete a full revolution and it continues for another negative 2 pi over 3. So that's an angle T. And we're going to need sine, cosine. We need the XY coordinates of this point. So let's see. From the, after one revolution, it continued for about, this is a negative pi over 3, this is negative 2 pi over 3. And if I draw a vertical line to the x-axis, so we always use x-axis to create the right triangle. And this is my reference angle, the angle between terminal side and x-axis. So that's going to be 60 degrees of pi over 3. And this small one is going to be 30 degrees. The hypotenuse is 1, so the side opposite from 30 is going to be 1/2. The side adjacent to 30, so that's going to be root 3 over 2. So now we can write down the XY coordinates of this point, which is going to be negative 1/2, so 1/2 in the negative x direction, and also root 3 over 2 in the negative y direction. So that's negative root 3 over 2. This is my cosine value, this is my sine value. And I already know 2 of the 3 trig values. So sine is negative root 3 over 2. Be careful when you write down the sine and the cosine, remember sine is corresponding to y, not the first number. When we write down cosine, sine always goes first, right? But when we write down XY coordinates, we put x first, so be careful. And the cosine of t is going to be negative 1/2, and then we can calculate tangent of t. So let me move it to the next line. Tangent of t equals sine over cosine, which is negative root 3 over 2 divided by negative 1/2. Now, earlier I showed you that you can just multiply by the reciprocal of the denominator, right? And then start canceling. I'm going to show you the second way. Sometimes some people will consider it the easy way. So here we have a fraction. So that's like the fraction line in the middle. And in the numerator, we get a fraction, the denominator, we get fraction. But both of the numerator and denominator have this denominator 2. So I'm just going to multiply by 2 to the numerator and the denominator. And I can start canceling separately. So 2 under the 2 in the denominator. In the numerator cancels. Same thing with the denominator part. They have a 2 and the denominator 2 cancels. So now what do we have? We have negative root 3 remaining in the numerator. We still have this fraction line, and there's just negative 1 in the bottom. So we can just drop the negative 1 because we get negative, negative is positive. So we get root 3. All right, let me show you the work. So what I did is I got negative root 3 divided by negative 1, which is just root 3. All right, any questions about what I did over here? Let's see. We don't have questions. We're going to talk about a few trig identities. Trig identity. Well, first of all, let me graph a angle. So let's see, this is my angle T. And below this x-axis, I'm going to use the green line. So this is my negative angle, negative T. And this is the point in the first quadrant is going to be x, y. This point, now, if I thought everything correctly, those points could be symmetric above the x-axis, right? So this point in the first quadrant, it's going to still have a positive x, and it's going to have a negative y because the y is in the negative y direction. So if I rewrite x and y with sine and cosine, what do I have? I have x is cosine of t, the y is sine of t. And in the point below, because I have an angle negative t, so I get the x is cosine of negative t. And the y, I don't know why I put in, so that's a negative y. So the negative y as a y coordinate is equal to sine of negative t. Does that make sense? So what I did is, at first, I wrote down the x, y coordinates for each point by using the x value. So that's the x value, and this is the y value. And then for the negative, the terminal side corresponding to the negative t. So again, the x coordinate is still going to be x, but the y coordinate is going to be negative y because it's in the negative y direction. So that's the y coordinate. And then I just rewrite the x, y using sine and the cosine. So the first x corresponding to cosine t, the first y corresponding to sine t, and for the negative angle t, the first x corresponding to cosine negative t, and the negative y at the y coordinate corresponds to sine of negative t. So now let's see if we can draw any conclusion about those two angles. So what do we know? We know that so x is equal to cosine t, and x equals cosine negative t, which means from those two equations, we can see cosine t must equal to cosine of negative t, because both of them equals to the x value, the x. And then we know that y equals sine t, and then negative y is equal to sine of negative t. From here, if I substitute for the y with the sine t on the left, so if I put this into this y position, because y equals sine t from the first equation, so I get negative sine t is equal to sine of negative t. So here you have this two identities with negative angles. A common way to write it is actually flip backwards, flip the two equations. So we get cosine of negative t is equal to cosine of t. Doesn't matter what the angle is, the negative of the angle is the same thing as cosine of the negative angle is equal to cosine of the angle itself. And then we have sine of negative t is equal to negative of sine t. This is the more common way to write it. Sorry, cosine of negative t. All right, any questions about those? And then a few more, like I don't really see any point of memorizing but if you see it, try to think about what it means. For example, this one says tangent of negative t. What is that equal to in terms of tangent t? Well, tangent of negative t is equal to sine of negative t divided by cosine of negative t by definition. And the sine of negative t, we know that's a negative sine t. And the cosine of negative t is just cosine t itself. So then you have this negative sine over cosine, so that's a negative tangent. So tangent of negative t equals negative tangent t. And we can write down the similar equation for cosecant. So So cosecant of negative t is equal to negative cosecant t. And then secant of negative t is actually equal to positive secant t, because it has to do with 1 over cosine, has to do with cosine. Cosecant has to do with sine. Well, for sine, it's always a negative. And then cotangent of negative t is equal to negative of cotangent t. To be honest, those three are less used. Even if you see them, you should be able to figure it out by using sine and cosine there. All right, so those, I would say perhaps those two are probably the most commonly used when it comes to trig functions of negative angles. But there are more commonly used identities. You probably heard that the Pythagorean identity, which says sine square t plus cosine square t is equal to 1. So this is a very commonly used, because if we know sine and we don't want to use a calculator, or we cannot have access to calculators, then we can find cosine using this equation. And then we have 1 plus tangent square t is equal to secant square t. And then cotangent square t plus 1 is equal to cosecant square t. Now, I'm going to actually ask you to memorize this, especially if you're planning on taking Calculus 1 or Calculus 2 in the future. Those two are actually very useful at some point in calculus when you need to either differentiate or integrate. So if you do planning on taking Calculus 1 or 2 in the future, definitely remember those two. And obviously, if you remember cotangent square plus 1 equals cosecant square, that's good too. All right, any questions about those identities at this point? All right, let's use them to find a few examples. So suppose we have secant t is equal to negative 17 over 8 for the angle t is from 0 to pi radians. Find, let's just say find sine t, cosine t, tangent t, basically all 5 other trig functions. We have secant, so we need cosecant t, cotangent t. Okay, so how do we do this? Well, let's see. So all we know is secant, right? So we know secant is negative 17 over 8, and we want to find sine, cosine, tangent, cosecant, cotangent. Well, we could perhaps using the second equation to find tangent first, because we know that 1 plus tangent square equals secant square, we can find tangent there. I usually just go all the way back to sine and cosine and then use those two to find everything else. So let's see, we know that secant t is equal to 1 over, secant begins with s, so 1 over cosine t. And that's telling us that negative 17 over 8 is equal to 1 over cosine t. And I want cosine out of this, I'm going to flip both sides. So that's going to tell me that cosine t is equal to negative 8 over 17. That's cosine. And then you probably wonder, okay, now I have cosine and I want to find sine. What should I do? Well, we're just going to use the first equation, sine squared plus cosine squared equals 1. So we get sine squared t plus cosine squared, which is -8 over 17 squared, is equal to 1. All right, you know what? I just regret that I made the 17 there. I'm going to change this problem. I'm going to change 17 to 11. And just make it a little bit easier, slightly easier to do the calculation. So -17 over 8 is actually -11 over 8. So now we can solve for sine t. So we get sine squared t plus 64 over 121 equal to 1. I probably should change it to 10, which will be much better. Anyway. Well, actually, let me change it. It's okay. It's 11. All right. So we get sine squared t is equal to 1 minus 64 over 121. So that's going to be 121 in the denominator. So 121 minus 64. So that's going to be 57. That's sine squared. And the sine t, remember when we take a square root on both sides here, we should add a plus or minus square root of 57 over square root of 121, which is 11. Well, whether is it going to be positive or negative, right? That's why we have to decide. So we know that cosine is negative, and then we know we haven't used this information yet. We were given. Just a second. We were given this information, which we did not even use it yet. T, the angle is from 0 to pi, and we already know cosine is going to be negative, and we want to know which sign do we take, positive or negative, or maybe both. So here we're just going to draw a angle there. So we know the angle is going to be from 0 to pi, so it's going to be somewhere here. And we know that cosine is negative, so it's the angle is probably going to be somewhere here in order to have a negative cosine, negative x coordinate. Well, the sine cannot be negative, right? Because if it's in the second quadrant, the sine has the y coordinate has to be positive. So sine of t must be positive root 15 over 11, not negative, because of where the angle is. So we call that, we know that the angle could be somewhere here from 0 to pi, but because cosine is already negative, so the angle must be in this pi in order to have a negative cosine or negative x coordinate. Well, if it's there, then the sign has to be positive. It cannot be negative. Any questions? So that's, we found the sine, and we obviously found the cosine, right? For the rest, we can find the tangent using sine over cosine. So that's the root 15 over 11 divided by -8 over 11. So multiply by 11, both numerator and denominator, or multiply by the reciprocal of the denominator. So now we have root 15 over -8, or negative root 15 over 8. And we can also find cosecant, which is 1 over sine. So that's a 1 over sine is positive root 15 over 11. So root 15 over 11. So that's going to be 11 over root 15 multiplied by square root of 15. So that's going to be 11 square root of 15 divided by 15. Now the numbers are not nice, but it doesn't matter, right? We just need the expression. And one more cotangent of t. Usually we put a parentheses there. So that's going to be 1 over tangent. So that's 1 over negative square root of 15 over 8. That's going to be -8 over square root of 15 multiplied by square root of 15. Both numerator and denominator, so get -8 square root of 15 over 15.
I'm sorry, I might be slightly lost. Was it square root of 15 over 8 or 15 over 11 or square root of 57 over 11 for sine of t?
Oh my goodness. All right, that's a very good catch. Thank you so much. I don't know where I just begin right 15. 57 for all the square root part. That's a terrible mistake. So square root of 57 for all of them. Thank you. That's 57. Square root of 57. Anyway, 57. Square root of 57. And the 15 is 57. And a couple more mistakes to correct. 57, 57, 57, 57. Thank you. All right. Catch any other questions? All right, so let me stop there with this example. So in this example, we know the secant value. We don't know anything else except for that the angle is from 0 to pi, right? The range for the angle. And we were able to find sine, cosine, tangent, cosecant, cotangent, basically everything else. So generally speaking, if you know one ratio, you should be able to find the remaining part. You might have to use a few identities there or definition of those fixed functions. Let me ask you this. Does anyone want to see more example of this type? Let me know if we do. Like, for example, if you have not seen this material before, it's probably better for you to see more examples. But if you feel good on this material, you have seen it in the past, you feel like you don't need me to repeat more examples, then I'm going to do it here. Okay. Well, I'm sure we're going to have more opportunity to practice something like this in the future. But let's just do another quick example. So suppose we don't know the angle method, but we know that secant of angle T is equal to -2. So what is secant of the angle, negative angle, the angle -T? So here we know that secant of angle T is equal to -2. And we want to know what is secant of negative angle T, or perhaps what is cosine of -T. So here is kind of what we need, the negative angle identities. We know that earlier, with negative angles, we have cosine of -T equals cosine T, sine of -T equals -sine T, then we have tangent, then we have cosecant, secant, and a cotangent. So obviously that's a formula that says secant of -T equals secant of T. We can just use that directly. Or let's just say you don't have that, remember. Don't worry, just convert it to sine or cosine or both. So secant we know is going to be, so we call that secant of T is 1 over cosine of T. because we know that secant of t is -2, so we know that 1 over cosine of t equals -2. Flip both sides, so we got cosine of t is equal to -1/2. So that's cosine of t. But what about cosine of -t? Well, we remember that cosine of -t is equal to sine of, it's equal to cosine of t. So cosine of t is -1/2, so that's equal to -1/2. That's cosine of -t. And from there, we can find secant of -t, which is 1 over. So secant of -t is 1 over cosine of -t, which is going to be 1 over -1/2. That's -2. So just in case you don't have the exact negative angle identity memorized, you can always find it by you convert them to sine and cosine. You should always remember all the identities with sine and cosine. Okay, so that's this part. I want to ask you a question. Are you all familiar with using the calculator to find the angle? We're probably not going to do it at all, but I just want to check with you. Let's see, suppose I give you a question that says, using the calculator, to find, let's see, cosine of 11 pi over 5. And I hope that you all know how to type that into the calculator and find it. It depends on the calculator you have. Some of it you can just type in directly. Some of it you might have to enter the angle and then press cosine. But if you have a graphing calculator or some calculator that that being like, I don't know, maybe 10, 20 years old, you should be able to type this directly. If you have a trouble with that, let me know. But with a graphing calculator, the first thing you want to do is you want to make sure that it's actually in the radian mode, because this is not degrees, this is the radians. So I would say make sure calculator is in radian mode. If it's not, or if it's impossible to convert to radian mode, just convert the radians to degrees first and then put that into the calculator. Any questions on this? All right, shall we take a quick break? All right, let's see, why don't we do this? We haven't done, so why don't you, looks like I can see everyone's name or picture now. Why don't you raise your hand if you want a break? If you don't want to break now, I'm just gonna finish talking whatever I need to talk about, and then at the end we finish early. It's up to you. I'm imagining that I'm probably going to take another maybe half an hour. All right, I'm
all set to continue going if you are.
Okay, well, if you're all set to continue, in that case, let's just continue. But if anyone else wants to take a break, just raise your hand. We can definitely take a break together. All right, on that note, let's continue. I promise you it's not very, because we already talked about the big part, which is finding the sine and cosine using the unit circle. So that's taken care of, so the rest shouldn't be that bad. All right, so that's the next section, 5.4. We're going to use right triangles to find trig. So for example, use the triangle below. to find sine alpha, cosine alpha, tangent alpha, and then cosecant alpha, secant alpha, and cotangent alpha. And the diagram given is this one. This is 65, 56, oops, 33. This is the angle alpha. Now, this is, I don't think this is something new to you, because if I recall correctly, back then when you first studied sine, cosine, tangent, this is actually the first thing you learned, which is using the right triangle to find sine and cosine, and that's probably defined, right? So if you remember SOHCAHTOA, for most of us, that's how we were taught. So the way I like to write SOHCAHTOA is SOHCAH and the TOA. I like to put the opposite in the hypotenuse in this vertical order instead of horizontal order, but it's all the same. So sine is opposite over hypotenuse. So this angle alpha is here. This is the hypotenuse, the side opposite from the right angle. And this is the adjacent, and this is the opposite. So sine is opposite over hypotenuse, so that's going to be 33 over 65. Cosine alpha is going to be adjacent over hypotenuse. Adjacent is 56. Hypotenuse is 65. Tangent, opposite over adjacent, so that's going to be 33 over 56. Okay. So we got this part. And then what about cosecant? Well, that's why we have to remember cosecant is just 1 over sine. So if you take 1 divided by 33 over 65, so that's 1 times the reciprocal, so 65 over 33. Hypotenuse over opposite. And the secant is going to be 1 over cosine alpha. So I'm going to do it quickly. So that's 1 over 56 over 65. So we get 1 over 56 over 65. So that's going to be 65 over 56. Cotangent is just 1 over tangent. So that's going to be 1 over the fraction. So it's going to be the reciprocal of 56 over 33. So it's relatively easy if you're familiar with it. Okay. Now I'm going to add one thing here. So that's sine alpha and the cosine alpha, tangent alpha, all those. Let me move this to the left a little bit. And move this triangle to the left. Now, what if I want to say, let's say this is a beta. So alpha plus beta is equal to 90 degrees or pi over 2, right? Or you can write as beta is equal to pi over 2 minus alpha. So they're complementary angles. And I want to find out what is sine beta, cosine beta, tangent beta, and keep going, cosecant beta, secant beta, and cotangent beta. So let me erase the hypotenuse and well, I'm going to leave them there. So for beta, I'm going to use the blue color here. So the hypotenuse is still the hypotenuse. The opposite side of beta, angle beta, is now 56. And the adjacent side of angle beta, so now is this 33. So sine is going to be opposite over hypotenuse, so that's going to be 56 over 65. Cosine is going to be 33 adjacent over 65. Tangent is going to be 56 over 33. And then cosecant beta, it's going to be 1 over sine, so that's going to be 65 over 56. secant is going to be 1 over cosine, so that's going to be 65 over 33. Cotangent beta is going to be 1 over 10 beta, so 33 over 56. Now, why do we go through this? Well, now I want you to think about, because alpha and the beta are complementary angles, I want you to compare their sine and cosine values. It's not that difficult to notice that sine alpha is actually equal to cosine beta, right? And the cosine alpha is actually equal to sine beta. That's always true for complementary angles, which is sine of the angle alpha is equal to cosine of the angle pi over 2 minus alpha, beta, the complementary angles. And then cosine alpha is always equal to sine of the complementary angle pi over 2 minus alpha. And what about tangent? Well, tangent is 33 over 56, and it's not the same as the tangent, but it's equal to the cotangent. So we get tangent alpha is equal to cotangent of pi over 2 minus alpha. And the cosecant alpha, 65 over 33, that's secant beta. So cosecant alpha is equal to secant pi over 2 minus alpha, and so on. All right, I'm not going to write down the rest. To be honest, the rest is really not used a lot. It's good to know, but it's not really useful to actually write down everything. Let's just say, suppose I give you one of those problems on the homework. I really expect you to know really those two. The tangent, I might throw it in there, but even if you don't know that, you can always try to think about the definition of tangent and cotangent to figure out. But I just don't see any point of memorizing all those. And even if you memorize it, let's see, when you actually need it in a calculus class, you probably just end up looking it up. All right, so that's a complementary angle quick functions. Now let's look at some examples. So if sine of t, which is 5 over 12, we don't know what the angle t is. So we're going to find cosine of pi over 2 minus t. Well, we know that t and cosine pi over 2 minus t, so those two angles, t and pi over 2 minus t, they're complementary angles. So when you add them, you get pi over 2. So sine of one angle is equal to cosine of the other angle that are complementary. So that's cosine just equal to sine of t, equal to 5 over 12. Another example. So suppose we have cosecant pi over 6 is equal to 2. Well, let's just see, we don't even know that, or actually we do need to know. I know we're going to find secant of pi over 3. Let's see, obviously we can find secant pi over 3 by finding cosine pi over 3 first. You probably already have it memorized. In that case, you can just use your memory. But in this part, let's just see, we don't have it memorized what secant of pi over 3 is. How do we find it? Well, I know that pi over 6, 30 degrees, pi over 3, 60 degrees, they're complementary angles. So those two angles are complementary. Which means, do we have a relationship between cosecant and secant? Well, the answer is yes. So cosecant alpha and the secant of the complementary angle should be the same. So we know that cosine pi over 2, sorry, pi over 6 is 2, then secant pi over 3 is 2. So that's equal to cosecant pi over 6. Any questions on those? All right, if you have a question, I have another example, which is a little bit different, which actually go back to the SOHCAHTOA, basically. So the next example I have is solve the right triangle, which means to find all missing sides and angles. All right, so how do we do it? So here's a right triangle. This side we know is 30 degrees. This is the A, this is C, this is 7. Let's call this the angle A, this is the angle C. We know it's 90 degrees. Let's call this B. All we know is the angle, 30 degrees, and then the side opposite from it is 7. How do we find A or how do we find C? Well, first of all, let's try to find perhaps C. So we know that 7 is opposite from 30 and the C is the hypotenuse. And then we can, okay, so we know opposite, hypotenuse, and then the angle, this must be sine. So we get sine 30 degrees. It's equal to opposite, which is 7 over hypotenuse C. And we need to find C. Do we know what sine 30 is? Well, based on what we memorized so far, we know that sine 30 is going to be half. That's equal to 7 over C. And then we can find C by cross multiply. So C equals 14. So that gave me C, which is 14. Now, what about A? How do we find the side labeled A? Well, we can use tangent because that's adjacent side. So tangent 30 degrees is equal to adjacent opposite 7 over adjacent A. And do we know tangent 30 degrees is? Well, we probably know it already, right? Which is going to be sine over cosine. So let's just say you don't know tangent 30, so that's sine 30 degrees over cosine 30 degrees, 7 over A, but which is also sine 30 degrees is half. Cosine 30 degrees is root 3 over 2. That's equal to 7 over A. So here we can cross multiply again to get 1/2 times A equals 7 times root 3 over 2. Multiply by 2 on both sides, we get A equals 7 root 3. And then we can figure out angle A because B is already 30, C is 90, so A and B are complementary. The measure of angle A is equal to 90 minus 30 equals 60. You've probably done that many times already. Now, I just want to use this example to show you that you could solve for the sides by using sine and cosine. There are definitely other ways we can solve it by using ratio of the special 90, 30, 30, 60, 90 triangle. All right, any questions on this? All right, let me go through one more example here. It's a little bit different, but before we talk about that, let's just review two type of angle that use a lot in some real life examples, which is angle of elevation and angle of depression. So angle of elevation, basically, you look directly in front of you and then you look upwards, right? So that's the angle of elevation. Angle of depression is you look directly in front of you, but then you look downwards. So I'm going to draw a diagram like this. So let's see there's a person standing here looking, right? So this is right in front of the person and then he's looking upwards. So this angle here, it's called the angle of elevation. That's not a good representation. So that's what this angle is, angle of elevation. Now let's see the person moves and is standing here. And this line is directly in front of that person and he's looking downwards. So that creates this angle. And that's the angle of depression. I'm being a little bit lazy. I'm not going to write the words, but that just want to show you where they are. So here's the example. It says, how long a ladder is needed to reach a window scale that is 50 feet above the ground. Now this problem is long, but when we solve it, it probably wouldn't take that long time. Above the ground. If the ladder rests against the wall, making an angle of 5 pi over 12 radians with the ground. Okay, so that's a problem. It took a while to write it down, but I think when we solve it, we probably end up actually using less time. So if you see a problem like this, the very first thing you want to do, you want to draw a diagram just to understand what the problem says, because the diagram itself is going to explain everything. So let's see, this is the building, and here's a window. Let's see, this is the bottom of the window sill. And that's 50 feet above the ground. So this is the ground, and this is going to be 50 feet. And then the ladder is resting against the wall, making the angle of 5 pi over 12 with the ground. So let's see, there's a ladder here. And it tells me that the angle with the ground between the ground and the ladder is going to be 5 pi over 12. That's what we know. Okay, we want to know how long the ladder is. So let's see, this is just call it x. We don't know how long it is, but it's x feet. We know the angle it makes with the ground, and we know how far it reaches on the wall, 50 feet. And it definitely for sure that the building and the ground usually is perpendicular. No ambiguity there. Well, at least not in this case. So how do we solve for the x? Well, we know the angle and we know the opposite side. We're just looking for the hypotenuse. So this is the hypotenuse. This is the opposite side. And we know the angle. So we can say opposite hypotenuse, we're going to use sine. So we get sine of 5 pi over 12 is equal to opposite 50 divided by x, and then we can solve for x. But in this case, we have to use the aid of a calculator because we just don't know what sine of this 5 pi over 12 is. But let's see, I don't have a calculator. So I'm going to move the x to the left side. So we get x times sine 5 pi over 12 equals 50. And we can solve for x by divide by the sine expression. So 50 divided by sine 5 pi over 12. I don't have a calculator, so that would be my answer. It's exact. If you put in the calculator, it's actually an estimation. It's not exact anymore. So to be honest, in terms of the final answer, this is probably the better one than the answer you get once you put everything into the calculator. Any questions about this example or anything I talked about from the beginning? Like I said, you know, especially the second part, the one with the right triangle trig, you probably all seen it in the past. It just, you know, you probably need some review if you haven't seen it for a while. But the other ones, the tangent, the part we talked about earlier, you've probably seen them already. There's definitely a few identities. I wouldn't recommend memorizing all of them, but there's some important ones you do need to know. For example, tangent is sine over cosine, etc. You have to know that very well. And sine squared plus cosine squared equals 1. Sine of negative angle is equal to negative sine angle. Cosine of negative angle is equal to positive cosine of the angle. Well, any questions or comments at this point? Okay, well, again, like I said, I apologize for delaying the class, but it's just something that could not be avoided. You know, I don't imagine it's going to happen again in the future. But nevertheless, so anyway, so that's all I have to talk about today. And I'll try to make the homework available later tonight or tomorrow morning. Just watch out for the assignment. All right, take care, everyone. I'll see you tomorrow.
Thank you.
Thank you.
Okay, goodbye, everyone.
Thank you.
Yep, bye-bye. Hi, Tim.
Hi. Yeah, hi.
Question?
I had one question about the homework. Do you mind if I share my screen real quick?
Yeah. Oh, actually.
The one due on Sunday. I just completely forgot how to, 1 second, let me find the one I'm stuck on. How to, I don't know if it was like make it into a single log, but for some reason it says my answer is wrong.
Okay. Yeah, you should be able to share your screen now.
Oh, it locked me out of it. No. Let's see. It was. It was this one right here. Can you see it?
Right. I think that when you have to, so let's say you get natural log of y plus 1/2. That's correct. You have to continue to expand the natural log, the second natural log term.
So this term?
Correct. So the half you can just, you know, don't lose it. But the natural log of y over 1 minus y, you can expand that one more step further.
That's what I'm having trouble on. How would I go about doing so?
Okay, so the fraction is a quotient, right?
Yeah.
Y divided by 1 minus y. So if you have a division inside the
Oh, you just multiply it in the top quotient here.
Not quite. Let's see. Okay. All right, I'm gonna leave it there, so let me write this. Well, actually, I'm gonna stop recording. I don't think we need to record this.
Okay.